Hello everyone and welcome to McLean 360. So in this video I want to solve a question with you to illustrate the concept of the second moment of area. All right. So over here you can see that we've been given a rectangular cross section and we've been asked to determine the second moment, or let's say the second moment of area with respect to x and then y through the centroid. That's all. Okay, so the first thing we have to do is to locate the geometric center of the entire figure. And to do that, we have to find x bar, which is summation ai s bar I divided by summation ai. And then we've got y bar to be summation ai y bar I divided by summation ai. But you see, this figure over here is a complete rectangle. So we don't need to really bother about this. All what we have to do is to assume that the whole of this figure is nothing but a complete rectangle. How do I know this? So all what I'm trying to say is that this figure which we have here is actually, or can be taken as a complete, rectangle. And once we assume that this is actually a complete rectangle, then that will simplify the problem for us. Okay. So all what we need to do this time round is to assume that this whole body is a rectangle. Then for a rectangle, what do we know? We know that the centroid will be exactly halfway, and then exactly halfway. So in other words, the centroidal axis must be here. So this will be the x axis about the centroid, and then this will be the y axis about the centroid. Okay, so maybe let me do it well. So okay, so it's going to be something like this. Okay, all right. So now that is it for you. We've got our y c and then our x c. So we are not going to use this formula. All right. Okay. But what is our xc and our yc? It is important to know that this is 1, this is 4, this is 1. So if we add all of them up, we have 6. Okay, so this is 6 inches. So halfway will be what? Halfway of 6 will be 3. It means that all the way here is actually 3 inch. Okay, once you know that, that's all. And then also don't forget that this is 4. So if I divide 4 exactly into 2, I have 2 inches, and that's all. All right, so let's begin from the first area. We are going to divide the areas into area 1, area 2, and then area 3. All right, so starting from the first area, ixx1. Okay, so this is what we are saying. Ixx is going to be ixx1 plus ixx2 plus ixx3, where ixx is given by icj plus ad squared. So this is what we call the parallel. So it's called the parallel axis theorem. All right. So let's begin from the first area. From the first area, we have ixx1 to be about the centroidal axis. What is it? It's going to be bh cubed over 12. So 4. So this is what I'm saying. About the centroidal axis, the formula is given by bh cubed over 12. So 4 multiplied by 1 cube divided by 12 plus the area, which is 4, and then multiply by d squared. So when you say d squared, you want to ask yourself, now the centroidal x-axis is passing through like this, okay? And then you want to get this actual centroid, okay? So whenever you want to apply the parallel axis theorem, you need to pass an imaginary centroid through the area so that the distance between that imaginary axis and the actual axis will be the d squared. So in this case, you realize that if we pass a centroidal axis through this, it will be halfway of 1, which will be what? 0.5. Okay, that's all. But then don't forget that all the way here up to this point is 3 inch. So in other words, from the center all the way to this center is nothing but 3 minus 0.5 here, okay? And that gives us what? 2.5. So it's going to be 2.5 squared. All right, that's all. So we got 3 minus 0.5 will give us 2.5. Okay. Right now, we are done with the first part. But what is it? So it's going to be 4 multiplied by 1 cube. Of course, 1 cube is the same as 1 divided by 12. And then plus 4 multiplied by 2.5 all squared. And what is this? So 25.333 inch to the power 4. All right, now we are done with the first one. Let's come to the second area. So IXX2 will be the same thing. We are going to use the centroidal axis plus the area times the distance squared. But watch this carefully. With the second area, this distance here is 1. So it's going to be 1 multiplied by the height. Okay, and the height is what? 4. Okay, so please take notice of this. B, which is the width, multiplied by H, which is the thickness or the depth, cubed, all right, divided by 12. And that is actually the centroidal. Okay, plus A, which is the area. So the area is length, which is 1 times breadth, the height, which is what? 4 times d squared. But who can tell us the distance between the centroidal axis and then this axis we have here? You see that interestingly, if you take the second area and divide it exactly into 2, because this is 4, if you divide 4 into 2, it will coincide exactly with the centroid of the whole figure. What does it mean? It means that there is no parallel axis for the second area. Why? Because the second area has a centroid which exactly coincides with the centroid. All right. So here will be 0 for the second area. That's all. I hope the concept is clear. All right. So then for this one, it's just going to be 1 times 4. So 1 times 4 to the power 3. Then you divide here by 12. And that's all. And that is 5.333 inch to the power 4. And now finally, let's do the ISS for the last figure. So for the last figure, we are going to use the same approach, BH cube over 12 plus AD squared. But you see that for the last one, the the width is what, 4, and then the height is 1. So BH cube over 12 plus, and then the area is going to be 4 multiplied by 1 d squared. Now watch this, because this axis is where we are taking reference from, the distance from here coming down will be negative. But watch this, the parallel axis theorem, okay, if we actually draw some sort of imaginary x-axis through this one, okay, so this is your imaginary x-axis, which is actually the centroidal axis of the third area, then we can say that the distance from the actual centroidal axis of the whole figure compared to that of the third area, the distance will also going to be what, 2.5. But this time around, because you are moving below the x-axis, then it's going to be what, minus 2.5, because of course this is 1, so halfway will be 0.5, and we know that all this from here to here is 3, so 3 minus 0.5 will give us 2.5, but it is going to be negative because it's what, below the x-axis. All right, so minus 2.5 squared. So the issue is that if you make it positive, it doesn't change the answer, but if you make it negative, it means you understand what you are doing. All right, however, whether it's positive or negative, it doesn't change the answer. All right, now since this is similar to the first one, we don't need to calculate because it will give us the same results. All right, so then if we want IXS, then we are just going to add everything. So 2 multiplied by 25.33 plus 5.33, and what is that? So this is going to give us 2 multiplied by 25.33 plus 5.33, and that is what, 55.99. so 55.99, which is almost like 56.0 inch to the power 4. So in effect, this is actually the ISS, okay, that is to say the area moment of inertia about the x-axis, which is passing through the centroid of all of the figures. Okay, sorry, so that is it. Now let's do the same thing, but this time around we are going to use the y-axis. Okay, let's do the same thing. So for clarity's sake, let me clean everything I've done for the x and let me only do for y. All right, so since we are going to deal with the y-axis, we are going to use the same analogy, sorry, but you see something interesting here. Already you should not forget, so already you should not forget that the y-axis is coming all the way this way, something like this. Okay, yeah, and then it is passing through like this. Okay, so this is our yc and this is our xc. So again, we are going to say that Iyy will be Iyy1 plus Iyy2 plus Iyy3. But what is Iyy? Iyy will be Icg about y plus a d squared. So that is the parallel axis theorem. I think this one was supposed to be about the x. Sorry about that. So let's begin. Iyy1 is going to be what? So we just have to look at it. That is to say 1, 2, and 3. So for the first figure, the centroidal, instead of BH cube over 12, this time round it is about the y. So it is going to be HB cube over 12. Please don't be confused. So whenever it is about the y, it will swap and then it will become HB cube over 12. That's all. So looking at the first area, it's going to be pretty much simple. So h is 1, and then the b, which is the width, is what? 4. So it's going to be 1 4 cube over 12 plus area. Let's look at something interesting here. Now, assuming that you have the y-axis passing through this, the first area, you see that the actual centroidal of this about the x will be like this, okay? How about the y? So interestingly, to draw the y-axis of this area, I mean the centroidal y-axis, it will coincide directly with the actual y of the whole figure. In other words, the y-axis which will pass through the centroid of this will also pass through the whole centroid. Therefore, there is no parallel distance. So the parallel axis theorem will be 0 for that aspect. So 0, that's all. And if you look at the figure clearly, you can see that the y-axis is actually passing through exactly. So we are not going to worry ourselves calculating the parallel axis theorem. And this is where most people don't understand. It is very important to know that there is the actual centroid, there is the actual axis, and then there is the centroidal axis, okay? And whenever the centroidal axis of the individual figure coincide with the actual axis, then the parallel axis reduces to 0. Okay. So at this juncture, we just have to move forward to the second one, knowing that the parallel axis will also be 0. So for the second one, it's going to be b, no, it's actually hb cube. So h is 4 for the second area. H is 4, and then b is 1. So h is 4, and then b is 1 divided by 12. And then you add this to this one. It's going to be 0 anyway. So 4 multiplied by 1, 0. All right. So, and then finally with the last one, with the third area, so you see that the y will also pass through like this, okay? So it will actually pass through the exact centroid of y. But you see that for the x, this is the centroidal x of the figure. And then this for the second one, the centroidal x will be like this. But you see that interestingly, for the second one, the centroidal x was coinciding with what? The actual. And that is the reason why when we go to here, it was 0. So I want you to always note this so that it will be easy for you. All right. I could have just skipped it, but I'm writing it for you to know why it was 0. All right. So for the last one, we are not going to waste much time there. It's going to be hb cube. So h is 1, b is 4. So 1, 4 over 12, 1 times 4, 0. Okay, so let's compute what we have here. So for the first one, we have 1 multiplied by 4 to the power 3, then you divide by 12, and that's what? 5.33. So this one is 5.33 inch to the power 4, but we don't need to calculate the third one. It's the same thing, to the power 4. But then the second one, we have to swap it. And please, if you don't take care and just interchange them, the whole thing will be wrong. So you have to take your time and do it. All right. So 4 multiplied by 1 cube divided by 12. And that is 0.333. So then IYY of the whole figure is what? Is going to be 5.33 plus 0.33 plus 5.33. And that is what? So 5.33 multiplied by 2, and then what? Plus 0.33. So that is 10.99. And then 10.99 inch to the power 4 is almost the same as what? 11. So the final answer is actually 11.0 inch to the power 4. All right. So we've been able to find IYY and then ISS. So always do not forget the parallel as its term. And then whenever the centroid of the actual figure coincide with the the axis in question, then it's going to be 0 about the parallel axis. Thank you very much for watching.